In this video, we'll write the balanced net ionic equation for AgNO3 plus K2CrO4. This is silver nitrate, and this is potassium chromate. The first thing we need to do is balance the molecular equation. I can see right away I have silver here, and then two silver atoms here. So it looks like I'm going to put a 2 in front of the AgNO3. Now that I have two silvers, I have two nitrates and just one over here. I'm going to put a 2 in front of the KNO3. Two potassiums, and then I have a chromate on each side. So we're done. This is the balanced molecular equation. Now we can write the state for each substance. Nitrates are very soluble if you know your solubility rules. AQ, that means aqueous, dissolved in water. Potassium compounds, also, they are very soluble. But we get to the silver chromate. Silver often is insoluble, and if you look this up on a solubility table, this will be insoluble. That means these two things will react here, and this will produce an insoluble compound, and that's going to be a solid. So it'll fall to the bottom of the test tube as a precipitate. This will be a precipitation reaction. And then we have a nitrate here that's going to be soluble AQ. Those are the states. Now we can split the strong electrolytes into their ions for the complete ionic equation. Silver is always going to have a 1+ charge. The nitrate always have this 1- on the whole thing. So we have two silver ions, that Ag+. I'll write the states later. Let's not do that now. And then I have two of the nitrate ions, NO3-. For potassium, that's in group 1. It'll have a 1+ ionic charge, and the chromate ion, the whole thing, 2-. So I have two potassium ions, and then I have the chromate ion, the CrO4. And those are the reactants in our net ionic equation. For the products, we don't split solids apart, so we'll just have Ag2CrO4, that silver chromate, and then we said potassium is positive, the nitrate is negative, two potassium ions, plus we have two of the nitrate ions. And those are the products for our net ionic equation. And this is the complete ionic equation. At this point, we'll cross out the spectator ions. They're on both sides of the complete ionic equation. So in the reactants here, I have the two nitrate ions, and in the products. So I can cross those out. Those are spectator ions. Two potassium ions in the reactants. And then here in the products, we have two potassium ions. Cross those out, spectator ions. What's left? That's going to be the net ionic equation for AgNO3 plus K2CrO4. Let me clean this up, write the states. We'll have our net ionic equation. And this is the balanced net ionic equation for silver nitrate plus potassium chromate. You'll note that charge is conserved. I have 2 times 1+, so that's 2+ and a 2-. That gives us a net charge of 0 here in the reactants. In the products, this is a neutral compound, so its net charge is 0. So charge is the same on both sides. If you count the atoms up, they're balanced as well. This is Dr. V with the balanced net ionic equation for AgNO3 plus K2CrO4. Thanks for watching.